G'day trendsetters, Greg here from Fishplay Films, and welcome back to part 2 of our Tsunami 2 installation and preview. Now, first, a couple of things first. A few people have asked me, it's trend setters, T-R-E-N-D setters, not trend setters. A lot of people think it's train setters. Well, you know, it could be. We all started out, a lot of us started out with train sets. But no, it's trend setters, because we're setting trends. That's what we're doing in model railroading, new stuff and better ways of doing things and stuff like that. Also, trendsetters comes from an old comedian down here called Rodney Rude back in the 80s. He was quite rude, and he was funny in some cases, but a little bit lowbrow. But anyway, he had his funny moments, and he used to say trendsetters all the time. Different the way I said it, but that's sort of where it comes from. So there you go, that's that clear. Now, our Tsunami 2. First thing, with the settings on the back EMF, if you remember, if you watched the first part 1, we were talking about, I said that the Kato locomotive that we use, AC 4400, needed more back EMF than the other Katos, and I thought maybe the decoder was different. Well, no. Turns out, the more testing I did, the harder it was getting to get it to run slow under load and take off slow. Turns out the motor was faulty. Now, I've had it on a couple of Katos. We all know Kato motors are probably the best out there, but I buy all my locomotives off eBay because they're just too expensive down here, and I really don't know what people have done to them. They say they're brand new, who knows? So I've had a few that have failed, and if they're going to fail, they fail within hours of running, sometimes within half an hour. And if you find that motors start running erratically, and when you do CV settings, they change, and you have to keep going back and redoing start voltages and redoing back EMF and all that. If that's happening, it's your motor is a problem. It's very, very rarely it's the decoder. And with that motor, it was hard to turn. It had a couple of sort of binding spots. Now I thought maybe it just needed to run in a little bit. I should have listened to myself, trendsetters, and not used it, because I know I've done probably 30 Kato installs at least, and the motor should turn free the whole time. This would bind up everything. It wasn't a mechanical bind, it was a magnetic bind. So anyway, that's it. So there was nothing wrong with the decoder. We have another AC 4400 here that we're going to put speakers in today, and I did the old test with the flywheels, and it runs smooth the whole way around. Put another Tsunami 2 decoder in, I've got a second one, and it ran perfect out of the box, under full load, started on a hill, no problem. So the decoder wasn't the problem with our first one, it was the motor. So that's that cleaned up. Also, another thing to clear up, indexed CVs. I said that you need to read indexed CVs for the automatic sounds. Some of them you do, not all of them. So any CV that is under 255 you can read normally. Any CV that's over 255 you will need a system that reads indexed CVs. Okay? Or JMRI, which I now have. Thank you, Bryce and Greg from the Gold Coast to come up and help me install JMRI, my old laptop, the Batmobile as we call it. Some of you might get that joke anyway. So it's on there, and we managed to start up a bit of a locomotive roster today. Thank you, Bryce and Greg, for coming up. That's great. And well, that's one step forward to getting some JMRI signalling, isn't it? So there you go. Anyway, let's get into this, and we'll talk about speakers today, trendsetters. We're going to speak about speakers. If only we could speak about speakers in a speakeasy. That'd be trendy. Went to a speakeasy in Sacramento. It's now an Italian restaurant. Little. Okay. Oh, now, one thing I forgot. Sorry about the partial nudity. But I was going to dress up in maybe a BNSF shirt bought from the Tehachapi Ed's Trains, Fast Eddie's Trains at Tehachapi. Or I was going to wear the Quebec and New England. Sorry, Sheldon. I operated on this layout when I was in Toronto, and Sheldon very kindly sent me a shirt all the way from Toronto for operating on the Q and NE. That's a great layout, that one. But it's too bloody hot. It's 36, 37, so it's about, what, 96, 97 Fahrenheit? And the humidity's crazy. So this is what you get. 9% female audience, got to do something for them, get them out of the kitchen. Oh, that's going to come back. All right, Sorry, girls. You're welcome. Okay. Now, only joking. Let's get into speakers about speaking before I get shafted. Right, so we're going to be putting 2 speakers in this locomotive. One in the old fuel tank there, so that will be a 28mm. This is actually a lock sound speaker. Now I'll get on to why I'm using lock sound speakers. I have used in the other locomotive, the other AC 4400 that's got the dud motor in, I used a TCS WOW 28mm in the tank, and I used a Zemo, not the sugar cube, a Zemo 40 by 20mm. They call it bass enhanced, but it's a rectangular speaker in an enclosure, both 8 ohms. Now the reason why I've switched to these two we'll tell you in a moment. And the other speaker is a lock sound or ESU. It's a rectangular speaker, a little enclosure there, also 4 ohms. Right, so that's going in the locomotive right there. Well, actually that's the, yeah, that's right, it's going right there. Sitting in that spot there like that. And it's small enough once the light tubes are removed, because you can't use the light tubes, remember now, because these decoders obviously don't have the Kato lights, which is good because it forces you to do proper lighting. Theory is that there can reverb up through the body and out through the exhaust, which I drill out. I drill out all my, where is it? Drill out all my exhausts, which that one I haven't done, to let the heat out and also let some of the sound out. So that's what those 2 speakers are going in there. Now let's get into why I have chosen ESU speakers. Right, now why are we using lock sound 4 ohm speakers? Well, like all amplifiers, your home, your car, all that sort of thing, amplifiers are designed to drive a certain load. Forget about watts, all that sort of thing. The electronics in an amplifier are designed to drive a certain load. And by that I mean a certain resistance. Now, this is why speakers have resistance on them. Now, of course, it's not called resistance in audio, or it's called impedance. The reason why it's called impedance is because a speaker is like a small motor. It has a coil, it has an armature, and it has a magnet. So it's basically a linear motor, a speaker, if you want to really simplify it. And when you get a coil that starts moving the magnet inside a speaker, that starts setting up an induction, because it starts generating its own field in there. So in a really technical, basic sort of way, they call it impedance rather than just resistance. So each speaker has an impedance of 8 ohms. Now because of that, it sets a load on the amplifier, and that's what those amplifiers is to drive it. Don't talk about watts, it's impedance. And if you lower the impedance of speakers for an amplifier, so if you say put a 4 ohm speaker on an 8 ohm amplifier, that's less resistance, because remember it's less ohms, so therefore you would think that's better, but it's not, because less resistance means more current can flow. It's easier for the electricity to flow through the coil of the speaker. So therefore the speaker moves faster, or moves more, makes it louder, which you think, well, that's a good thing, but it's not, because it overdrives the amplifier, because the amplifier starts, it can push this speaker further and you can actually damage your amplifier. So, rule of thumb is, if your amplifier, including our decoders, recommend that they are driven, well, they drive an 8 ohm load, and that's what they'll sort of say, this amplifier is recommended to drive an 8 ohm load, or is equipped for an 8 ohm load, or drive into an 8 ohm load, you should try and keep it 8 ohms or greater. It doesn't matter if you go greater, because that's more resistance, so therefore less current will flow, and the speakers will be a little bit softer, but not much. So the rule of thumb is, if you're putting 2 speakers in a locomotive, Greggy's rule of thumb is, and then I've got my electricians and my sound techs hat on, because many years ago, Trends, you may not realise this, Trends, but I was in a rock band. That's right, I was a drummer in a rock band for probably 5 or 6 years, maybe a bit longer. And then I moved into the sound field, and I did sound for concerts and all that sort of thing in City Hall and other venues around Brisbane. So there you go. I don't have any formal qualifications, but as far as being an electrician. But as far as sound, I used to do quite a bit back in the 80s, the crazy 80s. No, it wasn't that good. Yeah. So, oh, I can tell you stories, and they're all so boring. Groupies? No, didn't happen. Anyway, 2 4-ohm speakers wired in series. So that's into one, out of the other, into another, and back to the amplifier is 8 ohms. That's what we want. 2 8-ohm speakers in series will give us 16 ohms. That's also good. It's higher. The volume will be a little bit less, but that's okay, because remember, we don't run our trains very loud, do we? No, because it's silly. It's very annoying. You don't hear all those fine little sounds, remember? Turn them down, 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 down. So that's good. 16 ohms is fine. You just have to turn the volume up a little bit more than if you run 2 4 ohms into 8. You put 2 8-ohm speakers in parallel. That's like both out of the positive and negative. 4 ohms. No good. They will be really loud, but you will damage your amplifier, i.e. your decoder, in the long run. So, bit of tips there from Greg. So what we're going to do is put these speakers in. Oh, now, before we do, I've got a bit of a drawing here, and we'll focus in on this in a minute, and I'll tell you what the go is with this. The positive and negative. The positive and negative on your speakers and on your amplifiers means absolutely nothing if you're using one speaker. Absolutely nothing, because remember, our speaker voltage is AC. It'd be no good if it was DC. Your speaker would just go, and that's it. It's got to go. It's all about moving air, isn't it? So your speaker voltage is actually AC. So the positive and negative means nothing, because it's going from positive to negative 150 times a second, or whatever the frequency is, I should know. The reason why they have positive and negative on amplifiers and on some speakers aren't even marked, is because when you install more than one speaker, they have to be in phase. So therefore, when the cycle comes around, your voltage out of your amplifier goes positive, negative, as it's pushing the speaker in and out. When the phase goes to a top part of the phase, both your speakers need to go either way. Now, the audio purists will tell you that when the sine wave is on the top, your speakers should go out. That's only if you're talking about super duper high end with these audiophiles, you know, that can hear if the speaker cable's only got 20 core instead of 25 core, those crazy audiophile people. But it doesn't matter. The speakers need to both go the same way. So that way on the positive cycle, that way on the negative, it doesn't matter. Speakers doing this, no good. They cancel each other out, and they actually make the sound quite muddy. Now, I can prove this on here. We need to get our speakers in phase. It may not come across the camera and audio that well, but in person, I proved it to one of my apprentices at work who knows nothing about sound, and I hooked up 2 speakers in the last locomotive with the first Tsunami 2 decoder, and he could tell when the speakers were in phase and when they were out of phase. When they're in phase, they're a little bit louder and the sound is a lot cleaner. So that's why we have positive and negative on our speakers. So we'll get into this, and I'll show you this, and then I'll wire the speakers up, and we will do a phase test and get these 2 speakers in phase. Now, if your speakers are all marked with positive and negative, that's fine. You just go through and wire them as you would do in series. Positive and negative, negative, positive. But one of these isn't marked. So we have to do a phase test. So let's wire these up and get this done. Now, the easiest way to do phase testing is to hook up one speaker permanently. So in other words, this one here. And then the second one, because we're in series, you just leave the 2 leads off and swap these 2 leads around to see which way the speakers sound better. So we're going to come out of the decoder. Now I've set it to positive. It doesn't, as I said, it doesn't matter. So we're wiring in series. So we go out of the decoder into one speaker. Now I marked this positive and negative. As you can see, this speaker here is marked. This one here is not marked. Doesn't matter. Now remember, if there's one speaker, polarity doesn't matter at all. So we're going out of the decoder into one speaker, positive, out of the other one in negative, just in and out, doesn't matter. Come to here, leave the wires disconnected. Come out of the other side of the decoder, in this case we come out of the negative, come around, and we've got here. So technically we've got a negative lead, or let's say a negative phase, and this side we've gone through this speaker and we have a positive phase. Now, depending on which way we connect these two wires to this speaker here, will tell us whether it's in phase or not. So what I do is I will solder a couple of wires onto here and then have these two wires loose and then use a couple of little alligator clips and swap the connections around on this second speaker, and when it sounds better, then we know we're in phase, trendsetters. That's it. Righto, trendsetters, we've got it all hooked up now, and one of the random sounds is going, so we'll crank it up. Now, what we've done is we've got this speaker here with two wires coming out, a red and a black. So that's represented here, our red and our black. Our fuel tank speaker is already wired up, so that's this one here. So we've got one wire coming up from our fuel tank speaker. This is so loud. The wire coming up from our fuel tank speaker is this one here, coming up through the hole in the decoder. So we'll call that our tank wire or our speaker wire. This other wire here, coming from the decoder, is this one here. So we'll call that our decoder wire. So we've got, at the moment, we've got our red wire from our speaker, which is this one. It's hooked up to our decoder wire. So our red one here, at the moment, is hooked up to this one. And our black wire from our speaker, this one here, should be hooked up to the speaker wire from the tank, which it is. Okay, now that's quite loud, but I can tell, just because I've done this before, that this is wrong. It's a lot of high pitch, it's sort of fuzzy, a bit blurry, and there's no, let's call it bass. Remember, we don't get bass in these speakers. To make bass, you need to be able to move air. We're not moving any air, or very little anyway. So I just know that that's wrong at the moment. So what I will do, I will transfer this red speaker wire here. So this one here, at the moment, it's connected to our decoder. So our red speaker wire is connected to the decoder. I'm going to move it and connect it to the tank wire. So I'm going to connect it over to this one here. So let's try that. So we'll take that one off. Shouldn't be doing this while the speaker's running. Okay, so that's our other end there. I'm removing it from the decoder wire, the red speaker wire, and I'm going to put it to the fuel tank wire. There we go. And the negative, make sure that doesn't hit the, make sure that nothing hits the decoder when you're doing this stuff too. So now the negative is going to go to the decoder wire, where before the negative was going to the fuel tank wire. Now let's see. Whoops. Now straight away, you might not be able to pick it up on the audio, but now I can hear the thumping of the engine. The more, I'm not going to call it bass, but it's a deeper sound. And things are a lot clearer now. You can probably tell it doesn't sound as loud either. It's not as annoying like it's... So that's it. We've now phased our speaker. Right, trendsetters, let's recap what we've done. We've come out of our decoder. We've gone down to the fuel tank speaker. That's with this brown wire here. We've come out of the fuel tank speaker. We've come up. That's this wire here. We've gone to our positive. Just so happens that it is the positive. Remember, initially we had it on the negative. And then we've come out of the negative with this one here, and we've gone back to our decoder. Now, of course, before, our red and black were swapped around on these two, and it was out of phase. So now we've swapped them around. It just so happened that the red is on the... Don't worry about the positive and negative. It wouldn't matter if none of these had positive or negatives on them, as long as you went from this one, a daisy chain, through here, stopped here, out of the decoder. These are your two wires that you swap on the second speaker to get the phasing correct. And we've done that, and I'm going to put a body on now and see what it sounds like. Right, trendsetters, here we are. Now it's quite loud with the body on, and I actually turned the prime mover down to 150. So that's 150 out of 255. Still way too loud. You can hear there's a lot more presence there now the body's on. It's a lot better than with the, obviously, no body on. Now, we'll go to speed step 1. So this is straight out of the box. Haven't touched any programming. Now, with the other loco that we did on the previous video, it wouldn't run at that speed step. It was very jerky. I had to put lots more back EMF in. So if that happens, you know, start looking at your locomotives possibly. So I had a hunch that that's what it was. And anyway, so this is a typical Kato now. Haven't touched a thing. All I've done is turn the volume down a little bit because it was too loud. With the CV 131, I think it is, prime mover. And of course the compressor, everything has to be turned down, and that prime mover will be going down even more. But that horn's crazy loud. So now with those speakers in phase, you can hear the lower frequencies more now. I'm not going to say the word bass. It's all about the bass, about the bass. There we go, and the compressor's quite loud too. The compressor's way too loud. So is the prime mover, still too loud. I'll probably be turning this down to probably 100 or 80 out of 255. This is the first time I've used that small rectangular lock sound speaker. It's quite good. I've drilled out the exhaust, and you can hear the sound actually coming out the exhaust from that speaker which is here. I have to move it back a little bit because the housing is fouling on the exhaust here, so it's going to muck around with that a little bit. And of course the 28mm in the speaker, in the fuel tank. Of course no settings. Yep. Alrighty. You hear the turbo spooling down there. Alright, very good. Right. Well, what have we learned today? Or as someone famously said in a movie, what have we learned, Palmer? If you know what movie that is, kudos to you, extra points if you can see what scene and movie that's out of. Well, what have we learned today? We've learned that speakers have impedance, and you should keep that impedance to what the manufacturer says of your amplifier. In most cases, including our decoders, it's 8 ohms. So, if you keep your speaker impedance to 8 ohms, with our little sheet here, remember, 2x4 ohm in series is 8 ohms, 2x8 ohms in series is 16. We can go above the ohms, above the 8 ohms, but we don't want to go below, because that lets too much current flow and will overload the amplifier, because it's trying to drive that speaker. So we've learnt that. The importance of getting our impedance matching our speakers. We've also learnt to phase speakers. So that's very important. Getting our speakers in phase. Ooh. So both speakers are moving in or out at the same time. They're not fighting with each other, one going forward and one going back. So there you go. When it comes to speaker placement, and noise. Remember, too much noise can be annoying. You know, you don't want these background noises going when you're trying to do something. So it's very important with your decoders that you turn all the sounds down. Otherwise some sounds aren't being drowned out by other sounds, you know, that's annoying. You don't want that. You want to be able to hear your decoders, hear all that, those nice little nuances. All those sounds that you've paid a lot of money for, you want to be able to hear them. If you have prime movers and that turned up too much, you can't hear them. Remember, quality trendsetters, not quantity. Well, that's what I used to tell my old girlfriend anyway. Anyway, I'm going to have a latte, because it's what us gentlemen do sometimes. So I hope you've enjoyed Speaking of Speakers and our part 2 of our Tsunami 2 install. Very impressed with the decoder, especially now that we're running it on a locomotive that doesn't have a burnt out engine. So there you go. So we will see you in part 3, which will be motor tuning and speed matching. And we'll see you then. And Happy New Year. And today is, 2nd of January today. It's bloody hot, so that's why we're upstairs and not in the shed. So, hooroo for now, and we'll see you on the next one. Bye-bye. Gotta get better with my latte art, you know. Not that easy to do. Oh, that's crap.